So we talked about parabolas previously in the context of functions, specifically quadratic functions, in the form f of x is equal to a times x minus h squared plus k. You guys learned about stretches, shifts, and transformation of base points. To generalize parabola, to talk about it, whether it's a sideways parabola or up and down parabola, we have to really look at what the definition of a parabola is. If you visit this bit.ly link, which I'll do here in a second, this was created by our very own Nick Franklin, and it talks about many different features of a parabola. So I wanted to have that link up there for you. It takes a little bit of redirection. But coming back here, a parabola is a, well, the definition, all points equidistant from a fixed point and a line. This is about us describing objects based on distance. So I want to kind of go back to all points. If you have like distances that are fixed, all the points that are equidistant from a single fixed point is a circle. All the points equidistant from two fixed points is a line. And all lines can be described as equidistant from two fixed points. That line is also called a perpendicular bisector. Now I have a fixed point and a line. And if I want to get all the points that are the same distance from the point and the line, distance from the point is just direct distance. Distance from the line is a shortest distance possible. So here's a point that's the same distance from here as it is to here. Here's another point that's the same distance. But all of these are also points. And all of these are also points. And if I kind of picked a point here and looked at its distance to the point and its distance to the line, those should be congruent. So all points equidistant from a fixed point and a line. The focus is that fixed point. It's a fixed ordered pair that is the point that we're kind of drawing our distance from. It is not a point on the parabola itself, but it is a descriptor point and one we're going to be using to figure out lots and lots and lots of other points. Another thing about the focus is that it is along the axis of symmetry. And it should be apparent to you based on the symmetries you've done before what we mean when we talk about an axis of symmetry. The vertex is the midpoint. It's the midpoint between the focus and this line here, which is the fixed line, which is called the directrix. The parabolas we are going to be describing, just make sure this is recording, the parabolas we're going to be describing are all going to be horizontal or vertically aligned parabolas. But you can have other ones. I mean, all I need is a point and a line, and I can draw a parabola around just about anything. So it's useful to know. Now, the thing about the directrix is that it is always perpendicular to the axis of symmetry. And the axis of symmetry, and well, I don't want to say too much about that. I think it's pretty obvious for you guys what it means, what it comes from. But let's move on to how we're actually going to construct these. So I have some kind of creations of what a vertical parabola is and what a horizontal parabola is. Let me kind of pause these and link to and see what these are. Awesome. So those links are dead, and those will be removed from your notes handouts. But the idea behind the vertical parabola is you guys all did this a equals x minus h squared plus k, and that's fine. But what we're going to describe is this distance between the vertex, which lies right here, and two other places, this focus and this directrix. And this distance here we're going to label c. And that distance c has a value of 1 over 4a, which also means that a is 1 over 4c. Now the proof for why that is has to do with really a way that we can get the definition, or that use the definition of a parabola to derive its formula. If I call this point right here hk, which I know that that is the vertex of a parabola, and I define this distance here to be c, then I know that this point is h comma k plus c, and this equation is y is equal to k minus c. And if I sort of pick an arbitrary point here and do its distance from here to here, and I call those congruent, then this distance would have to be, let's call this xy, this distance would have to be the square root of x minus h squared plus y minus the k plus c squared equals, and this distance here would have to be, well, it would just be y minus k minus 3, so it's equal to y minus k minus 3. If you take this and work it around, you're actually going to get y equals 1 over 4c x minus h squared plus k. You're actually going to get that. That's kind of longer than I want to spend time on at the moment. If I talk about a horizontally aligned parabola, so I have an xy axis, let's put a vertex here, let's put a focus here, and let's call this right here a directrix, and then draw these around here. So this is a horizontally aligned parabola. It opens left and it opens right, and it has an equation of x is equal to 1 over 4c y minus k squared plus h. So we did have this. This was an a value before, and it's still true that a is 1 over 4c. And that can be derived in a very similar process to what came before. So in summary, if I have a y equals parabola, it's going to open up or it's going to open down. And x equals will open right or it will open left. And to determine that, you look at the leading coefficient, and if it's positive, then we're talking up and right, and if it's negative, then we're talking down or left. So this creates like a little chart for you. You don't really have to memorize this. You should just reason through that that's how it has to be. Okay, the next set is kind of easy. We're just going to look at how to fill in the missing pieces and graph these things. So I'm going to graph a vertex at 4, 2. And a directrix at y equals negative 3. Vertex, directrix. Given that the vertex is always halfway in between the focus and the directrix, this c value here is equal to 5, and that would put my vertex directly above, or sorry, my focus right above here. So the focus would be at the ordered pair 4, 7. Finally, it says state the direction the parabola opens. This one opens up because it would have to look like this. We're going to sketch a graph. I want this graph to be good enough to have a single other point. So what I'm going to do, I know that these points right here are separated from each other by c. The focus is c units away from the vertex, and the vertex is c units away from the directrix. I'm going to look for points that are actually 2c away. And to do that, let me kind of erase this. I am going to go left and right from the focus 2c units away. So I'm going to go left 10, and I have a point there. That's 10 units away. This point right here is 10 units away from that and 10 units away from the directrix. Those are 2c units away, which gives me another ordered pair that I can use. Now, I'm way too far off the graph to do it to the right, but I can at least sketch this piece of it and see how wide this is actually opening without guesstimating too much. So that's a sketch. And finally, the equation would be y is equal to 1 over 4 times 5, x minus, my hk is 4, 2, so x minus 4 squared plus 2, and 1 over 4 times 5 is 1 over 20. Next, my directrix is x equals -1, so I'm going to go vertically like that at -1, vertex at 2, 1. So this one's going to open right. I can see that my focus is going to be 3 units away from my vertex, which will put my focus right here. Focus would then have an ordered pair of 5, 1. I'm going to draw, okay, so my direction the parabola opens, it opens right, and I can see that because that's how it's going to have to be drawn. My 2 C points, well, C units away from the vertex, this is 3 units and 3 units, so that 3 plus 3 is 6. I'm going to go 6 units here and put an ordered pair. And again, you may be wondering, why am I putting an ordered pair right there? Well, that ordered pair is 6 units away from the focus and 6 units away from the directrix. So it is an ordered pair on the graph. I can put a second one down here and have that be an ordered pair by symmetry, because I know that an axis of symmetry lies right along here. But finally, if I want to sketch a graph, I'm going to sketch it like this and like that. And my equation, well, the C value is 3, and it's opening right, so it's going to be x is equal to 1 over 4 times 3, 1 over 12, y minus my k value is 1 squared, plus h is 2. Going to number 3, vertex at 0, 0, focus at 0, -4. So this is vertex, this is focus, and that means that directrix is right above it, same distance away, that's 4 units, so this would have to be 4, and it's going to be a horizontal directrix based on the alignment of the vertex and the focus. So given that, it opens downwards, and the missing piece was the equation of the directrix, which has an equation of y is equal to 4. If I plot the points that are 2 C units away from the focus, that would be 8 units, so I'd have to put 1 here and 1 here just off graph. That would be a sketch that would look like this and like that. And the equation would have to be a y equals negative, because it's pointing downwards. 1 over 4c, so 4 times c value is 4, so 1 over 4 times 4, 1 over 16. X minus 0 squared plus 0, so this is just x squared. Lastly, if I... So lastly, if we're going to graph the focus at 1, 2, and the vertex at 3, 2, and so if the focus is at 1, 2, and the vertex is at 3, 2, then the directrix would have to be on the other side of the vertex. So the other side of the vertex is going to be right here. That's an equation of x is equal to 5. I know the graph opens left. I know that my 2 C points would be here and here, because those are 4 units away from the focus and 4 units away from the directrix. If I graphed it, I would graph it like this. And I would have an equation of x is equal to, it's opening left, so it's negative. 1 over 4 times 2 would be 1/8. Y minus the k value is 2. And squared, and the x value is, or the h value is 3. So let's do some from start to finish. Graph showing all of these things. So symmetrical points, these are my 4 C points, and we'll kind of show those here in a bit. I know that 1 over 4 C is equal to 1/12, because that's the A value, which means that C is equal to 3. I know that HK is 3, 2. So if I graph 3, 2, I know that the graph opens up because it's a positive leading coefficient and it's a y equals. So 3 up and 3 down is the focus and the directrix. So the directrix I'm going to graph as a horizontal line. Then my symmetrical points, my 4 C points, so now I have 4 C points, my 2 C points. C is here and here, so 2c is 6, 6 to the right, 6 to the left. That gives me 2 other points. Let's do intercepts. So it's going up. There are no x-intercepts. Provided I'm correct, then I can verify that. But when I subtract 2, I'm going to get a negative square root. So that matches. My y-intercept would be 0 minus 3 squared, which would be 2 and 3/4. So if I graph 0, 2 and 3/4, that goes here. And then I'm going to use the axis of symmetry to put the corresponding point opposite the axis of symmetry. So opposite the axis of symmetry is right here. Corresponding point goes like that. And this should match and line up pretty well once we graph it. Next, this one's going to be a little bit tricky. I know that 1 over 6 is equal to 1 over 4c, which means that c is equal to 3/2. I know that hk is the ordered pair 4, -2. Remember, they're reversed since it's an x equals. And I know this one opens left. So if I graph this, 4, -2, and I have a c value of 1.5 to the left, puts a focus, and 1.5 to the right puts a directrix. So get that halfway between. And my 2c points are to go 3 up from here and 3 here. Those give me the symmetrical points to graph. Let's do intercepts. X-intercept occurs when y is 0. So when I plug 0 in for y, I get -2/3 plus 4, or 3 1/3. If I go right 3 1/3, it puts me here. And then if I go opposite the axis of symmetry, the axis of symmetry is right here, that's how it should fold over, then I should put another point right here. Finally, let's do y-intercepts, which in a function in terms of y will act like x-intercepts. So y-intercepts, we go 0 is equal to -1/6 y plus 2 squared plus 4. Subtract 4 and multiply by 6, and I get 24 is equal to y plus 2 squared. This means that y is equal to -2 plus or minus 2√6. If you're approximating this, you should have a good sense of this. I know you're going to have a calculator, but you may not and only have a baby one. What is the square root of 6? So I'm asking Siri, because I want to show you can do a little bit of this by hand.
The square root of 6 is approximately 2.44949.
So we're just going to go 2.4 when we graph this. So let's factor the -2 out. 1 plus or minus 2.4, which is about, if I do 1 plus 2.4, it's 3.4. So -2 times 3.4 would be -6.8, or 1 minus would be -1.4. -1.4 times -2 is 2.8. So -6.8, 2.8. 2.8 would be right here. -6.8 would be there. And yeah, that matches. Look at the smoothness of that curve. So that goes like this, and that goes out like that. You can really make these look nice if you get intercepts, symmetrical points, and everything going. Okay, number 7, not quite completed. That's okay. We can complete the square on this. I'm going to put the, let's move the x squared to this side, x squared plus 4x. And I'm going to move all the other crap to the other side, -8y plus 4. And to complete that square, I'm going to want to add a 4 to both sides, half the middle term, and then squared. So this is going to be plus 8 if I add the 4 to both sides. You get x plus 2 quantity squared is equal to -8y plus 8. And then when I manipulate things, kind of back around again, I get -8y is equal to x plus 2 squared minus 8, or y is equal to -1/8 x plus 2 squared plus 1. So all of that just to get this equation into a decent graphing form. Let's move this up a little bit, and then we'll kind of get back to the the schema of starting this and graphing this. So this is going to be a downward parabola. I know it has a vertex at -2, 1, so -2, 1. I know it has a C value of 2. Shouldn't need to figure out, see how that is anymore. So we're going to go up 2 and put a directrix because it's a downward one. So that's going to go a horizontal line, and then down 2 and put a focus. Right from the focus, we're going to build the 2 C points, 4 over and 4 over. I know it has a y-intercept at, if I plug in 0 for x, I get -1/2 plus 1, so that's 1/2. The 0, 1/2 is a y-intercept, and opposite the axis of symmetry is the same corresponding point. Just for the purposes of being complete, we're going to put the x-intercepts, so 0 is equal to -1/8, x plus 2 squared plus 1, or 8 is equal to x plus 2 squared, or x is equal to -2 plus or minus 2 root 2, or -2 times 1 plus or minus root 2. 1 plus root 2 is 1.4, so 2.4, so -4.8, and then 1 minus would be -0.4, so 0.8. And let's see, -4.8 is going to be like right here, -0.8 is going to be like right there. And if I zoom in, well, touch is being really tricky right now. I get, there we go. Well, that's hard to keep that. That's better. Okay. Lastly, this one is going to be one where I'm going to want to complete the square on the y. So if I get, let's move the y squared plus 6y to one side and the 4x plus 7 to the other side. Add 9 to both sides. I get y plus 3 squared is equal to 4x plus 16. Subtract 16 and divide by 4, and I get y is equal to 1/4 y plus 3 squared minus 4. And I know that c is equal to 1, hk is -4, -3. If I graph -4, -3, I know that this parabola opens right. And since the c value is 1, this is going to be really tight. So the directrix would be located 1 unit to the left. The focus is 1 unit to the right. My symmetrical points are here and here. My x-intercept would be located at, well, if I plug 0 in for y, I get 9/4 minus 4. 9/4 minus 4 is 9/4 minus 16/4, or -7/4, or -1 3/4. And if it's -1 3/4, that's right here, and its opposite corresponding point would be right here, opposite the axis of symmetry, of course. And then we just need to do y-intercepts. So y-intercepts occur when x is 0. So if x is 0, then we get 0 is equal to 1/4 y plus 3 squared minus 4. Add 4 and multiply, and we get y plus 3 squared is equal to 16, or y is equal to -3 plus or minus 4, or 1 and -7. And if I put that at 1 and -7, and then graph it. And I believe that's it.